We're gonna do number, it says number 1 here, but it's supposed to be 5. And as there's several problems with the same number, and all the numbers are all messed up. Let's start. Let me tell you which one. It's the analysis of a sample of ibuprofen. The active ingredient in Advil shows that the sample contains 7 point, and this is pretty. It's the simple one. The other one, the mental, is a little bit more difficult, so that's why we're gonna go ahead and do both of them. Um, let's start with this. Carbon. Contains 7.568 grams. Hydrogen contains 0.881 grams. And oxygen contains an oxygen is gonna be 1.55 grams. Now, in this problem, we don't need to assume 100 grams because they are already giving us the grams of each one. So the only thing you have to do is convert each one to moles by dividing by the atomic mass of each one. So the carbon is 12.011, and it would be grams per mole. And if you're dividing by the molar mass, the unit would be mass, moles over mass. Here, moles over grams. Grams per mole or moles over grams. And here would be 1.0079 moles per grams. And here would be 15.9994 moles per grams. So now we cancel out the grams and it's giving us moles. And I'm gonna give you the answer is you divide each one, right? Each of them by the molar mass, smaller mass. So you're gonna get here carbon would be 0.63008985, then moles, right? And then we have here for the hydrogen we have 0.87. This is a good example because I think, yeah, this has decimal. For you'll see 0.944652 moles, and the oxygen would be the smallest one, which is 0.009694135 moles. Now we divide by the smallest one. That means that we will divide by 0.009694135 moles by 0.096944135 moles zero point zero nine six nine four one one three five moles. Now for carbon, this is gonna give you, when you put the subscript is the number of atoms per molecule, or the number of moles of atom per molecule, but it doesn't have a unit. It doesn't really, because it's a count number. So you eliminate the moles and the ratio does not have a unit. of course, it's like counting dozen or moles. 1 mole of pencil, 1 mole of pear. So it's not really specifically. Because if you count atoms, you would have 2 atoms, for example, 5 atoms, 2 atoms of oxygen, 1 molecule of O2, or 2 moles of atom per moles of molecules of 2 moles of oxygen atoms in 1 mole of CO2 molecule. So we got this is 6.9997. This would give you 9.016, and this is going to give you 1. Now, this is a decimal, how I said. You cannot round it. And to give you a limit for you guys, there's more for 0.888, but you cannot round it because then you change. If you round, the reason is if you round one of each, you're changing the ratio. That's why. But to give you, you're not gonna get more than that. So if it's higher than 0.75 and lower than 0.25, greater than 0.25 and lower than 0.75, you cannot round it. No rounding. And let me give you that just in case. 0.75 and 0.25 is 1/4 and 3/4, so you need to multiply by 4. Point 0.5, of course, by 2 to eliminate it. And 0.6666 and 0.3333 you multiply by 3. Now, just to make sure this is a comma, remember to multiply all. Because if you multiply by 1, again, you're changing the ratio. So how can we, this is 6.5. How can we eliminate 6.5 here? Well, we multiply by 2. And if it's that way, we can get rid of that decimal. And it would be um, 13. Then we have to multiply, right, all of them by 2, which if you multiply this by 2, again I'm doing the same thing, by 2, it gives us 18, and if you multiply by 2, this gives you 2. So the empirical formula for the Advil would be, mm, so here would be 13, right? The empirical formula would be C13H18O2. You see, you cannot, this is empirical, the smallest whole number ratio for this problem. Let's do the next one, the menthol problem. And this is, menthol is a flavoring agent extracted from it. It contains carbon, hydrogen, and oxygen. I like to put X, Y, and Z because that's the empirical, that's what we're trying to find out. Even molecular, but now we're finding the minimum whole ratio number, which is the empirical. Plus oxygen, because it's a combustion, right? Yields CO2 plus water. Now, one thing you don't know exactly. Now, one thing you have to be clear here that the 10 grams of substance, we're going to use it, but not because the hydrocarbon is C and H, right? And we didn't need to use any grams of the menthol. For example, here, yes, because you're going to have a C, H, and O. And I'll tell you what we're going to do. We're going to do the same thing as hydrocarbon exactly, but we can find out the grams of this by subtracting the grams of this to the 10 milligrams or grams. We can get the oxygen. Now, tell you right away something. As we're determining the ratio of milligrams and grams is going to be the same. Okay, we can assume grams is identical because remember what we're finding out is the mole ratio as it is a ratio. Okay, so anyway, let's do it like that and you see, and I explain it after you see it. So let's go ahead and let's use and assume grams, okay, instead of milligrams to simplify it. The ratio should be the same. So here you got CO2, you got 28.16 grams, and you got 11.53 grams of water. So what do we do first? Exactly like we did the hydrocarbon. We find out the grams, the moles of CO2. Moles of CO2 would be equal to, let's use that as a gram, 28.16 grams divided by 12.011 moles per grams, right, equals, and this should give you 0.6363,985. I didn't get more decimal, but if you can do it, moles. And the hydrogen, and this is the moles of CO2. The moles of water would be equal to 11.53. Do we all agree? Yes. Grams divided by the molar mass of water. Uh, I'm sorry. The 12 is not the carbon. I was doing the carbon here. I am so sorry. This molar mass would be the molar mass of CO2. And I'm gonna just give it to you, okay? And then you can calculate it. We already know how to calculate a molar mass, right? So it's 44.0098. And the water, yeah, and it still gives you that number because I already did this problem myself before starting this, so I know the results. So that way I wouldn't waste time doing the calculations with my calculator. We need that time for the video. So we got divided by 18.015 moles per grams, and it gives you for hydrogen, for water, it's gonna give you 0.064 moles. Now, how I said, if you want to determine the moles of carbon and hydrogen you have here, you know that for each mole of CO2 you have 1 mole of water, of carbon. So the moles of carbon, this is equal to the moles of carbon, which is going to be 0.63,985 moles. Now, the hydrogen, as we have 2 hydrogen in 1 molecule of water, the number of moles of hydrogen would be double. So the number of moles of hydrogen, you multiply by 2 the moles of water, right? Because you have for every mole of water, 0.64 by 10 to the 10 moles, you have twice the number of moles of hydrogen. And remember, we're counting different things, okay? So it's difficult to see, but the only thing you can know is that you have 2 hydrogens in one molecule of water. That means that the number of moles of the hydrogen atom is double the amount of moles of the CO2. So you got here 0.6402222204 by 2 would be 1.280044407 moles. Now let's divide by the smallest one, which is the carbon. And usually when you have a compound like that with carbon and hydrogen, the carbon is gonna always be smaller than the hydrogen. We haven't got into the oxygen yet, but I'll tell you why. Because if you try to do it with the oxygen from CO2 and the oxygen from water, it's gonna get really messy. But really, because you would have to add them, but how do you know which one of water or not? So the best thing to do here is to the best thing to do is like, okay, carbon does you only have one carbon on the right side, right, on the CO2, and the hydrogen comes from the water, period. So we're doing the same thing as the hydrocarbon. Now I'll tell you how you're going to find the moles of oxygen, because we need them for the ratio. Remember, now it's a compound that contains oxygen too. So we need to find the substrate. By the way, this is a C as in zebra, this one here on this oxygen. Yeah, because the point here is that okay, I find the moles of carbon here has to be identical to this one. The moles of hydrogen here has to be on hydrogen in the water has to be identical to this one. Okay, but my the problem here is that when you go with the oxygen, you also have oxygen gas here. You know, it's gas, the combustion. So we go here and it's O2, oxygen gas, and we divide by 0.63985 moles. Okay, a moles, and this is gonna give you 1 mole of carbon, and that's our X, right? The subscript of carbon. And this is gonna give you, and I'll tell you right away, for hydrogen, I did do it with your calculator because the problem what I did here. I no, sorry, we need to find the oxygen first. That's why I was looking at my calculation and I said, what did I do? Yeah, I am sorry. I am a little bit tired, but I want to have this done for you guys before the exam. Okay, here, okay, we don't do this step yet. Why? Because we have to find oxygen. Because we haven't. Remember, the empirical formula we're going to find out is the menthol, and the menthol have hydrogen. So here, it's not like the hydrocarbon. This part is identical. Okay, we found out the number of moles of carbon, okay, and we have found out the number of moles of hydrogen. So now we're okay. That one we did according to the hydrocarbon identical. If we didn't have oxygen, number of moles of carbon here is equal to the one on the left, and number of hydrogen here is equal to the left. Yes, those moles we're going to use it. But we have a problem now, different from the other one, is that we have oxygen. Now, how I said, if we have 10, if we know the sample, right? We assume gram, but if we know that the total sample is 10 milligram, or we're assuming grams, 10 grams, right? The total. If you find out the grams of carbon, the grams of hydrogen, and you subtract it to 10, you can get the grams of oxygen. Okay? The same thing like we had percentage. So now you got the moles of carbon. So how can we find out the grams of, we're going the opposite from grams of CO2. This is the step, gram from CO2. Grams of water to moles of CO2, moles of water. Moles of CO2 to moles of carbon, which is here. And moles of water to moles of hydrogen. We got it here. But now we don't have the moles of oxygen. Okay? But we can find it out. How? Well, we have, and let me write down the step. We have the grams of carbon and hydrogen. Let me write a solution map. The first thing is find moles of CO2. Okay? 2. Moles of CO2 is always equal to the moles of carbon. 3. Find moles of H2O. And number 4 would be moles of hydrogen or moles of water by 2 equals the moles of hydrogen. That's step number 4. Now, step number 5 would be convert moles of carbon, not CO2, moles of carbon and hydrogen to grams. Why? Because next step 6, we're gonna find out the grams of hydrogen, of oxygen. How can we find the grams of oxygen in the sample, in the compound? Well, if you have total mass or total grams of the whole compound, I miss a U here, sorry. Compound is going to be equal to the grams of oxygen plus the grams of carbon plus the grams of hydrogen. Remember what I was saying? This is a definite proportion. So if you find out the grams of carbon, the grams of hydrogen, and you have this, with this equation, you can find out the grams of oxygen. Okay? But how do you find the grams of carbon? Well, you have the moles of carbon, right? So, and you have the moles of the hydrogen. So the next step, once you know the grams of oxygen, what do you have to do? Divide grams of oxygen divided by the molar mass of oxygen. And what does it give you? The moles of oxygen. Now you can do what I was starting to do, like you normally do for empirical formula. Now you got the moles of everything. Initially, the moles of carbon, moles, moles of carbon, moles of hydrogen, and moles of oxygen. A little bit, a little bit of work, a lot of work on this problem. And you can divide by smallest to find the empirical smallest number of moles. So let's go ahead and do this. I draw you like the steps to solve this problem. So let's go ahead and from here, let's multiply the moles of carbon, okay, and the moles of oxygen. Let me do something here, of hydrogen. And we know that the grams of the sample is 10, right? 10.0. Um, I, why? Gonna have to put a pause because I'm taking too long for that. Okay, I think I got it. I need space here. So now I'm gonna copy down here, right? The moles of carbon and the moles of hydrogen to find out the grams. Copy. Uh-huh. Okay, so now let's find out the grams of each one. How I said why? Because we wanna go ahead and subtract it from the 10 grams of sample and find out the grams of oxygen so we can find in the sample so we can find out no matter the sample it is that's definite proportion no matter how many grams the amount of oxygen and carbon and hydrogen in this compound the ratio is always going to be the same so that means that we can use the 10 grams of sample so we got here right we got that this is the moles of carbon. If we multiply by the molar mass, atomic mass, or molar mass of carbon, which is grams per moles, we're gonna get the grams of carbon. Okay, and that gives you. Those are the results I was looking at. 7.685. 7.685 grams. Guys, I told you, let's work with grams and because this is a ratio, so it doesn't matter if you work with milligrams or grams here. Okay? And this gives you, right? You multiply this by 1.0079 by 1.0079 grams per mole, and it gives you 1.29 grams of hydrogen. So now we got these two values, right? So what do we do next? Okay, we get the total, the total sample, the total mass of the sample is 10.0 grams equals the grams of oxygen. That's what we're trying to find out. Plus the grams of carbon, 7.85 grams. Plus the grams of hydrogen, right? Now what we're gonna do is just subtract 10 minus this 2 and it gives us the grams of oxygen. So it would be 10.0 grams minus 7.685 grams minus 1.29. Okay, so the grams of oxygen. Do you know why we're doing all this? Because we need the moles of oxygen to be able to divide and find the ratio of the three elements in the formula. So the grams of oxygen would be, let me put the results here. Okay. The grams of oxygen would be equal to, how I said, if you subtract 10 minus 129 minus 7.86, if you want to do it, this equation here, right, this subtraction, it is going to give you that the grams of oxygen would be 1.024 grams. So what do you think is the next step? And look at the steps I wrote. Remember the step I wrote if you took note. Now we find the moles of oxygen, right? Why? Because we want to still find the ratio. Don't lose track of what we're doing. So we divide by 15.9994 grams. You remember the empirical that we did. Find out the moles of carbon. Find out the moles of hydrogen. Now find out the moles of oxygen, right? And then we divide everything by the smallest one. Oh, look with the pennies. Okay? So, okay. So this is going to give you 0.06, which seems the smaller one, 64071 moles. Okay, let's go up and compare it to the other ones to be able to do what we usually do for empirical formula. So the moles, now this is hydrogen, right? The moles of oxygen would be 0.064071 moles, right, of oxygen. So now divided by the smallest one, the oxygen moles, because that's the smallest one. Okay, if I can do a straight line. Okay. Oh. Well, doesn't matter. You're not gonna 0.064071 moles, right? 0.064 071 moles. 0.06407. Of course, oxygen gives you 1. That's why I remember, oops, I forgot the moles of oxygen. And I was starting to do the empirical without the oxygen just a few minutes ago. So this is going to give you, for hydrogen, I'm going to have to do it because I don't remember very good. I think this is 10. Yeah, this is going to give you like 10 something. I don't have the number here. I did it directly in the computer. This is going to give you, let me give you the results. This is going to give you 10, right? Oxygen is going to be 1. And the hydrogen, this is going to give you 20. This is 1. And this is 20. So the empirical formula for the menthol would be C10, hydrogen 20, O. O1 if you want to put, so there's no confusion, but you know the subscript 1, you don't write it. Let me see how much we have in the on this video so I can start loading them anyway. Yes, I'm gonna load it. I'm gonna stop it here and do a second one because it's already 34